Hello, this is now question 7 for the January 2003 Edexcel Mechanics Unit 1 paper. Now, we're given a situation, question 7, I've kind of drawn it for you. So, we've got this ball that is levitating 1.5 metres above the floor. Someone throws it up with a speed, we don't know, they call it U metres per second, just to confuse you. And obviously it reaches maximum height, so therefore it's going to end its velocity because obviously gravity is going to say no, you can't go any further, young ball. And it's got the height. So it gained a height 25.6 metres above where it started. So therefore, because it started 1.5 metres above the ground anyway, the maximum height it achieves is 27.1 metres, which is not key for the first bit, but as we go through it will become more apparent. Okay, so to sum up, this is what we've got for part A. We've got the distance it reaches is 25.6 metres from where it was. Obviously the acceleration due to gravity is negative 9.8, and we're not outside the atmosphere, so we don't need to consider the physicsy bit. I could prove that right, it's 9.8, but I don't think you'd be interested. Anyway, we know it obviously stops at a given point at 0 metres per second. We want to work out what U is. So, a perfect SUVAT equation would be, you go, okay, well, it's going to have to include U, these numbers. Okay, so the one that includes at best is V squared equals U squared plus 2AS. Because we don't know the time, we can't use the other V equation, and there's no one that includes U. Right, I guess we could have used SE, yeah, but it wouldn't. Anyway, so that's the best equation to use. So just sub in what we know, so that's 0 squared is equal to U squared, which is, we don't know, so we just call it U metres per second, and put square brackets there. Take away, remember, 2 times 9.8 times the distance, which is 25.6. Okay, so if you work that on your calculator, you should get, so if we move this onto the other side, so we get U metres per second, and remember that's squared, is equal to 501.76 metres per second, square root both sides, so therefore you get U metres per second being equal to 22.4 metres per second. And it tells you that's what you're supposed to get. It said prove that, but I didn't tell you that because you're really supposed to ignore it. Okay, so part B is a little bit harder. Part B says the ball reaches the ground after time t. After it's projected from A. So we call this point 1.5 metres above the ground, we call that point A. And it says obviously it's gone up, reached the maximum height, and then fell back down again. It says, so find the time, find 2 decimal places the value of t. Now, the way I'm going to do it is not, I'm going to do it in 2, well, I'm going to give you my way, and then see just how I feel about doing the next way. So really what I'm going to do is just put U metres per second as 22.4 and rub all this working out. So I'm assuming that all this is okay with you. I mean, it's just really SUVAT equations. And we've got to find out not just the time it takes to get to the top, we've got to find out the time, probably should use proper rubber actually. So basically, obviously the ball goes up to 25.6 metres above where it was, and then down 27.1 metres because it's got to hit the floor. Okay, so we're working at the whole time of it getting up there, stopping, and coming back down. Okay, right. So hopefully that makes sense. Okay, so what we're going to do is I'm just going to rub. Never mind. Obviously my room is that clean. I know where everything is. Right. So what I'm going to do is break it into 2 stages. The first stage I'm going to call this using all of this information, because all of this information tells us the bits that we need to use to be able to work out what how long it takes to get up to the maximum position. Okay, so what we want is t, and we've got s. So a good thing to do would be to split it up into the first stage and second stage. Now, the other way that I was going to show you is sort of combines all of this into one. But I think it's nice to be able to, in your head, just break it down. I mean, we're going to do that way for the second part of the question, because I haven't got another way to do this and follow this kind of method of breaking it up. But anyway, we'll get into that later. So the first stage, we want t. And we've got the distance, 25.6, acceleration, negative 9.8 metres per second, v is 0, and u is 22.74. Now, there's a couple of ones we could use here. We could use s equals a half u plus v times t, or we could use s equals ut plus a half at squared. In this case, it'd be take half at squared, because we've got negative 9.8, because we're going away from the centre. But a simpler one that we could use is the acceleration formula, which is the one I'm going to use, which is v equals u plus at. Obviously, it's going to be v equals u take at, but that's the proper formula. So sub in what we know, so obviously 0 is v, u is 22.4 metres per second, take 9.8 times t, so therefore put 9.8 times t on the other side, so we get 22.4 metres per second is equal to 9.8 times t. Divide both sides by 9.8, and I'm just going to rub it off on the board because I can, and I can't bother writing it again. So 22.4 metres per second over 9.8 metres per second squared, or whatever, equals t. Okay, so if you did that in your calculator, you would get an answer. Just put down my thing. There it is. So you would get an answer of 2.3 seconds. However, because we're breaking it up into stages, I'd write the full thing on your calculator. This is why I guess they probably haven't done it like this. So t is actually equal to 2.285714 seconds. Now, obviously, in real life it wouldn't be that, because we're not considering the effects of air resistance, so there's no effect from that. Okay, so that's the time, really. I mean, it's not going to make too much difference if you just rounded it to 2.3 and use that in your next part. You'd be incorporating some error, which obviously in real life, again, you'd have resistance, so that'd probably make up for some of that. Okay, so the second stage now. Alright, so I'm going to turn this on its head. Now, we know because the final speed of this one, there's no difference between these two stage times. It immediately goes from this stage to this stage. It doesn't hang around in midair, levitate for 24 hours. As much as I wish I could do that, reasons you don't need to know. I'm not weird, by the way, I'm just stupid. So anyway, we just use the final speed from this is the initial speed to this, which is 0 meters per second. However, we also know the final speed is going to be 0 meters per second, because it's not going to go through the floor. It's not superhuman, because it's not human. It's going to stop at the floor, so it's going to have a final velocity of 0 for the second stage. The acceleration this time is actually 9.8 meters per second squared, positive, because it's heading towards the Earth, could kill a few people. The distance this time is not 25.6, because we're incorporating both of these, remember, to get our 21.7. So therefore, the distance is 21.7 meters. So again, you could use a number of formulas here, because what you want to work out is t. Sorry. So you've got a good selection there. You can't use v equals u plus at because we don't have well, you could actually. Yeah, you could use v equals u plus at, sorry. But I've done here, I've used s equals ut plus a half at squared. I'm just saying, you can't do this. Oh wait, so it's arguing myself, so brilliant. Not only having to go to the viewer sometimes, insulting myself, I'm brilliant at this. I do it for a job. Anyway, so put in what you know. Now, s is obviously 21.7 metres. You've got your u to be 0. So obviously that's going to cancel the ut bit plus a half at squared. So you just sub in your 9.8 meters per second. So half of that is 4.9. So you could just write 4.9 times t squared. Now I should have wrote half times 9.8 times t squared, but I'm lazy. And I'm just going to go straight. So divide both sides by 4.9, square root it. So t is equal to the square root of 27.1 over 4.9. And that t is equal to 2.35. Okay, and then it would continue. But I'd leave that answer in your calculator and then add it to 2.285714. You should get an answer when you round it to, because you want it to 2 decimal places, to 4.64 seconds. So remember, that is the time for stage 1 and stage 2. Now I'd write underneath that is equal to the total time. Okay, so hopefully that's helped. Now we're not at the end of the question. I just, I'm not skipping it off. I'm just obviously going to need to rub all this out. So what I want you to do is just copy that down if you want to. Not charge if you, but so just going to obviously copy it down, and I'll copy in the vital bits that we need to know for the next question. But you know, there's probably some things that rub off there. I didn't want to spend 10 minutes rubbing it off. So we'll see you in the next part. Right, so welcome back. This is now just rub that rubbish off the board and put on the key bits of information. Now, we don't need to, so what I'm going to do, obviously this question is asking us to work out the force because it stops when it goes into the sand and it slows down, it obviously gives a constant resistive force upwards. Now, the first thing we need to know is what speed did that ball hit the ground with first before this force was applied. Now, we know the acceleration, which is the acceleration to gravity, which is 9.8 meters per second, or negative 9.8 meters per second in this case. We know the time is 4.64 seconds to 3 significant figures. And we know the initial speed was 22.4 meters per second, which we calculated previously. So what I'm going to do is work out the final speed just before it hits ground, which will be the initial speed of the time period. Basically, we split it up into 2 time periods like we did at the start. So v equals u plus at, so u is 22.4 meters per second. Take at, which is 9.8 meters per second, times 4.64 seconds. Okay, because it doesn't hang around at the top for any period of time, it just goes straight back down. So that gives us a value for v, if you put it in your calculator, of v being equal to negative 23.07 meters per second. Okay, so that's your speed just before it hits ground. You don't really need to bother with think about the minus thing, but it's just how we work it out. Okay, so that is equal to v. Now we want to work out the second part. Okay, so if you split this off into a second part, so you say u2 is equal to the final speed of the first part. So this is the initial speed of the second part, the part where it hits the ground. So the initial speed is obviously 23.07 meters per second. Now the final speed is obviously going to be 0 meters per second because it doesn't continue going through the floor forever. We are told there's a distance into the floor of 2.5 centimeters. However, when you convert that to meters, because we're in meters per second here, it's 0.025 meters. Okay. Any other bits of information we need? No, should be able to work it out from that. And obviously we need the acceleration, because when we come to do F equals ma, we're going to need a, because obviously we've got m being the mass of 0.6 kilograms. So what we're going to use is formula v squared equals u squared plus 2as. Okay, and obviously that a is going to be negative, but we'll just write out the formula as it's presented. So that's 0 meters per second. Put that in brackets squared, just to show you're following the exact formula. Equals v squared, equals u squared, which is 23.07 meters per second. Now, this is why it's pointless if it's negative or not, because obviously you're going to square it. Plus 2as, that's obviously 2 times a times 0.025. 0.025 metres, which obviously shows A is going to be negative. So if you put that in your calculator, U20, I'd use your exact figure from here just to make sure you don't make any mistakes. So let me just put that figure in my calculator. 64, 2.4, take the answer. Okay, and then you square that. That gets you 532.314. So, because that A is negative, if you take it to the other side, we're going to make it positive, so we can simplify them down. So 532.317, etc. equals 2A, 2 times A times 0.025. Now if you wanted to, you could simplify that down straight away on the right hand side, but I'm not going to. 532.17, etc. over 2 times the 0.025 equals the value for A. And if you work that out, so this is why it's good to keep it in your calculator, 2.5. That gets you A as being minus 10,646. So A is negative 10,646 metres per second squared, which is, I think you'll agree, a hell of a deceleration. You'd probably die from that. I think you would definitely die if you were that ball. But you know, that's how things work. Anyway, so that's the deceleration. Now keep that, as I said, keep that, when you press the equals, keep that in your calculator, because we're going to be using the standard thing of F equals ma. Now F equals ma, so you put your mass in there, so it's equal to 0.6 kilograms times your acceleration. So instead of right now, again, I just sort of say, put the acceleration up to 2, so that five significant figures, so times 0.6. So that gets you a force of 6,387 newtons. Okay. All right. So hopefully that makes. Now it says 6,390 in the mark scheme just because it's doing it to 3 significant figures. So. Okay, so hopefully that helps. So that's question 7C done with. 7D, I don't need to do any writing for this. The only thing we haven't encountered is, it's the only thing you generally don't encounter, because aerodynamics is such a complicated subject, because obviously you have to work out, probably have to test it, come up with the exact shape, because this obviously, mine isn't very round, so you'd have to come up with some wonky ball coefficient of friction for air, and that would start to get a little weird. Probably start to do a few experiments to find out if that shape hadn't already been calculated, the coefficient of friction for it. But because we haven't, and we're only doing AS for the maths, it's not going to be that extreme. So it's quite a nice question, that one.